Hello, this is Mr. Harris with an example of a t-test for a mean. They used to call this the student's t-test. A professor decades and decades ago, his graduate students were doing research. Um, and again, it's difficult to get the actual population standard deviation if you can't look it up. It's difficult to get larger sample sizes. So that professor augmented the t-distribution. Um, The last unit I posted a few handouts describing the difference between the Z and the T distribution. I hope you read them, looked through them. Um, if this is the perfect normal distribution, again, as degrees of freedom changes, the T distribution approaches it, but generally it's off. So if that's the theoretical normal, the T is always a little bit higher perch and has wider tails. It's augmented, it's not as reliable, but as your degrees of freedom slash your sample size -1 increases, it approaches that. The better, higher your sample size, as long as you're under 10% of the total population for independence, um, the closer it is to the normal distribution. Okay, I'm gonna go ahead and find the T critical value in this situation as well using the table and the calculator, just for the heck of it. But let's look through this example. Okay. A job placement director claims that the average starting salary for nurses is $24,000. That's horrible. Thank God to the nurses union. Um, yeah, that's not a good salary to start. Um, I got these from an old book I used years ago, so I don't, it's just a word problem. But a job placement director claims that the average starting salary for nurses is $24,000. A sample of 10 nurses has a mean of 23,450 and a standard deviation of 400. Is there enough evidence to reject the director's claim at alpha equals 0.05? Because this whole entire sentence is about the sample of 10 nurses, that's the sample mean, and you make the assumption that this is the sample standard deviation because it's all in the same sentence. I'm even going to write this for the heck of it, just to label it. You also have this stuff down here. My sample size is 10. That's not a large sample, degrees of freedom, so 9 degrees of freedom. We throw out one sample size, sort of, we know we're off. We know we're off by more because we're using the sample standard deviation and a smaller sample size. So let's throw out one person just for a little bit more room in case we're off more than we think we are. Sample mean 23,450. Sample size alpha 5%. Population mean 24,000. Population standard deviation, we don't have that. So I'm going to X that out and write sample S 400. Okay. Is there enough evidence to reject? So now I'm reading it again to see, is it a one-tailed or a two-tailed test? The average starting salary, a sample has a mean. Is there enough evidence to reject? From reading that, now granted, the sample mean is less than 24,000, but that's not always enough. There is an argument to make it a left-tailed test. There's also an argument to make it a two-tailed test to see if it's simply different. Claims the average starting salary, a sample of 10 nurses has a mean standard deviation. Is there enough evidence to reject the director's claim? I would do a two-tailed test or a left-tailed test because there's not enough information to explicitly state. They weren't seeing, is it more than or is it less than? They were just wondering if it's different. Because our sample got a value less than, there's an argument for doing a one-tailed, left-tailed test. But I'm going to do a two-tailed for the heck of it. Um, my calculator, I might go into a left-tailed. At this point, whatever would get a significance would work. And you realize if it's left-tailed, there's more area on one end, or right-tailed. So if I'm not significant at a two-tailed, I will then flip and try to do a one-tailed to see if I am significant. Um, you give people multiple results, and then you let them choose based off of whatever they're trying to achieve in their research. But for the heck of it, I'm going to just do two-tailed because I haven't done that yet, because there isn't anything explicitly stating it's two-tailed or one-tailed. 24,000. We always start with the status quo because that's what we're gauging and sizing up. Mu not equal to, mu is equal to. In this case, we're going to accept maybe it's more than 24,000, maybe it's less than 24,000. Two-tailed, two-tailed. Critical value, 5%. This is one thing that's good. I almost went into auto drive. I almost just wrote down 1.96 because I'm so used to using that Z distribution, but I'm glad I reminded myself I have to look up the T critical value. So let's go to our table and see what's going on with our table. Another reason why it's nicer using the two-tailed or the two-tailed tests, we can use similar things for confidence intervals because all confidence intervals are two-tailed tests. Another reason why it might be easier to do that. So if alpha is 5%, we would go for the 95% confidence interval. And notice if you go up here, 95%, they automatically give you alpha divided by 2, 5% divided by 2, so on the left and the right side of the tails. So I'm going to try to find where this is with my degrees of freedom 9. Let me line this pencil up. 2.262. Double checking. 2.262. Very different from 1.96. 2.262. It's further out. It's going to be more difficult to attain significance, as it should be, because there's more error. I'm curious if this was a one-tailed test. At 9, 1.83. Notice I went to 5%. I'll test that with my calculator in a moment. But that's how you would use the table. Now let's try to find the critical value for the T distribution using the calculator. Inverse T, the area on the left side, 0.025, degrees of freedom 9, negative 2.26. So we would have, notice I did that based off the two-tailed test because I divide my alpha by 2. So that worked out well. I'll put a plus minus here if need be. Now let's do it if we did a left-tailed test where it would just be an entire 5% on the left side. Remember, 83s don't have an inverse T, but there is a TI-84 app you can download to use. Inverse T, 0.05. Yep, and just like I looked up in the table, 1.833. Notice the table here, they only give you one table, and they give you the positive. So you would have to remind yourself to add that negative sign in front. The calculator works from left to right, so it automatically gave you the negative. If you wanted to do a left one-tailed test, you can do that. I'm going to write this for the left just off to the side so I can see which one would give me my best answer. Okay, now I'm going to calculate my test statistic for a t-test and compare that answer to 2.262 or negative 1.833 and see if it's beyond any of these or if it's within these walls, bounded. Okay, 23,450 minus 24,000. Standard deviation 400, sample size 10. Notice we just use the sample size here. We don't use degrees of freedom. Yeah, negative 550. Okay, that's very, very significant. Way out there. Um, Even though 23,450 isn't that far from 24,000, I guess if you got such a low value, even though you had just 10, with such a minimal standard deviation, if we're looking at standard deviations away from even this mean, even using the sample mean, 23,600, it's beyond one standard deviation. This is the good thing about test statistics. I didn't think it would be significant because it's so close, but that's way out there. If this is the line of demarcation, and this is negative 2.262, negative 4.348 is way out here. I'm expecting a p-value of close to 1%. I think it's significant at the 1%. Now, granted, asterisk time is only a sample of 10. But this would be evidence to say, hey, we need another sample, a larger sample. We need more funding for this because it came so significant. And salaries is important. Okay. Let's try to do this in the calculator now before we finalize our results. And generally speaking, the good thing with left tail tests, it's significant there. It's definitely significant if it's left tail. It's actually even more significant. So I'm not worried. That's the good thing of having this test statistic and being able to compare it to the critical value. I don't know what the p-value is. I can figure it out though. Essentially, the p-value would be the proportion of the curve to the left of -4, which, you know, if it's plus or minus 3 standard deviations, then I think it's a 0.5% to the left and right of 3 standard deviations in either direction. It's going to be a really small percentage. But let's do a t-test and see how it is with this calculator. Using stats, my null hypothesis or the status quo, sample size or sample mean, sample standard deviation, sample size. I'm sticking with the two-tailed test. We got the same value, -4.34. Values will be slightly off because our calculator goes up to 10 decimal places and I cut it off to 234 just to keep things simple. So if things are slightly off from what you did by hand versus the calculator, it's okay. Look at that p-value. Remember I said p-values are almost close to 0? That's a 0.1% p-value. It's a very significant, very highly significant p-value. Yeah. And again, it's the proportion to the left or right of any test statistic. Okay. And notice in this case, we don't necessarily need to calculate the critical value. Either way is good. Both ways are helpful. The p-values relative to that. If it was not significant, your p-value would be greater than 5%, just like in the last one, when I think in the z-test, we had an alpha of 5%, but the p-value was like 9%, so it's not significant. And then spending a little bit of time to write the response. I'm just going to jump to the chase and summarize my results. we have evidence to support accepting the alternative hypothesis. Um, and because we got the negative value, I want to say it's less than. If we got a positive value, there's evidence for more, but with a p-value less than 1% provides evidence mean salary is less than 24,000. Yeah. Something like that. Essentially, think about this as a summary of your of all the calculations you did in 1, 2, or 3 sentences. $24,000 a year is bad enough as it is, and then they have the nerve to be shortchanging these nurses. There's evidence to say that whatever hospital or whatever's going on, you're shortchanging these nurses, and you need to do better. Call up the union and all that stuff. Okay. And again, it's easier to forget conditions, but always make sure random, approximately normal, and independent. This is a really old thing I created years ago. Your problem set and all of that, I made sure I added in an opportunity to remind you to check your conditions. Because if your conditions, if any of these don't pan out, this doesn't matter. This doesn't matter because any of these conditions means that there's so much error involved that this evidence is shaky. Yeah. So that's that. There's one more. I worked this out already. And once you do 1 or 2 of these, I think you get the gist of it. This is a z-test for proportion. Remember, we always use the z's for proportions because in this case, the standard deviation is based off the p hat and q and all that stuff. I'm gonna just let you look at this. A lot of times you will be given your x value and your n, and you have to calculate your own p hat. I'm gonna do this in my calculator. In this case, I know it's a two-tailed test because they have that statement at Ohio schools in Ohio is, or at schools in Ohio is 15%. So if they're saying it is 15%, we want to say it is not. Therefore, we're okay if it's more than or less than, is not. That's a two-tailed test. But let's just do stat tests 1 proportion z-test. That's the one we choose, 1 proportion z-test. The next unit is 2 proportion z-tests. Again, next unit, it's the same thing we're doing here. We're just going to click a different button. And it's going to be the difference of 2 p-hats versus comparing p-hat to p sub 0 or p naught. P sub 0, the standard bearer is 0.15. My x is 38. My n is 200. It's a two-tailed test. Calculate. Okay. So proportion does not equal. This is my z-score, or my test statistic, if you will, 1.58. This is my p-value. My p-value helps me out with significance. My p-value is 11%. So this is not significant, not even at the 10% level. My p-value, whatever it's less than, that helps us out with our significance. That little thing on top of that p, that's the p hat, that's the little triangle. So our p hat is 0.19, our sample size. So just from doing the calculator, your p-value is 11%, so it's not significant at the 5% level or even the 10% level. Make sure if you're going to be taking the AP exam, You write up and describe that you got this from the calculator. You provide your p-value. Um, Go ahead and maybe even plug this into an equation because they like taking points off if you're not giving enough work for a problem, yet they do allow calculators. Um, okay, that's it. I'm going to be going over a few quizzes. I'll be posting Party Sabetti video, but I think we're pretty much done with this unit, believe it or not. Once you work through a few practice problems and do the homework, things should work out. Looking forward to grading your quizzes, reflect, grow, all that good stuff. Hope everyone's doing well. Goodbye. Have a great day.